An ionic bond involves transfer of electrons. Our metal atom M has a low ionization energy, which means it's not going to be holding on to its electrons very hard. Our nonmetal atom X has a high ionization energy, so it likes to receive the electron. After the electron transfer, the metal, which gave up a unit of negative charge, is now a cation with a net positive charge. And the nonmetal, which gained a unit of negative charge, is now an anion with a net negative charge. And the ionic bond is the attractive force between the positive and negative charges on the two ions. A noble gas electron configuration is particularly stable, with 8 valence electrons. Therefore, stable ions will have the same electron configuration as the nearest noble gas. Metals lose however many electrons are needed to achieve the same electron configuration as the previous noble gas on the periodic table. Consider aluminum. It has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p1. It loses 3 electrons to form the aluminum ion Al3+, with the electron configuration 1s2, 2s2, 2p6, which is the same as neon. Nonmetals, on the other hand, gain however many electrons are necessary to achieve the electron configuration of the next noble gas. Consider oxygen. Has the electron configuration 1s2, 2s2, 2p4. If it gains 2 electrons, you get the oxide ion O2- with electron configuration 1s2, 2s2, 2p6, which again is the same as neon. When you combine aluminum ion with oxide ion, remember to do the switcheroo to get the right subscripts. Al2O3 is the formula for the ionic compound aluminum oxide. The bond in aluminum oxide is the attractive force between the positive electrical charge on the aluminum ion, 3+, and the negative electrical charge on the oxide ion, Af, for attractive force. Here's a balanced chemical equation for the formation of aluminum oxide from its elements, aluminum and oxygen. Let's track the movement of electrons in this reaction. In other words, how many electrons does each atom gain or lose? First thing we'll do is we'll break up the ionic compound on the right into its constituent ions. So 2Al2O3 gives us 4 Al3+ ions and 6 O2- ions. That means each aluminum atom had to lose 3 electrons. 4 times 3 is 12. Each of our 6 oxygen atoms, on the other hand, gained 2 electrons. So 4 aluminum atoms losing 3 electrons each is 12 electrons lost by aluminum. 6 oxygen atoms gaining 2 electrons each is 12 electrons gained by oxygen. And those 12 electrons that aluminum lost are the 12 electrons that oxygen gained. Hence, aluminum is the reducing agent, and oxygen is the oxidizing agent.